As we continue our journey with regards to the unusual embalmer's clots that have been noted since 2021 that the scientific community is largely ignoring, even though it's not going away and is still present in a significant number of bodies. The strangest thing is when science stops doing science. But we still don't fully understand these clots, and part of my journey is to continually ask questions and try and understand the mechanisms. Recently got an email and it was sharing about a stent, a cardiac stent that got blocked. And it made me think carefully about the mechanism. And I'm going to share that with you in just a minute. I'll make a quick update. Before I start, just a reminder that coming up in another few days, COVID boosters, are they putting you at risk? This may not be directly relevant to you, but it could be to a loved one. And the question is about primarily the strange pattern with regards to IgG4. Join us as we go through the science as to what's happening and the relevance that it can be to you or your loved one. So let's quickly get back to what I'm talking about today. And I'll share with you email communication that I was involved in that made me realize that this could be relevant. So here is what was said in the email, caught my attention. So someone who is an interventional, who has who has a friend who is an interventional radiologist, and in case you don't know, interventional radiologists are the ones who take out clots. Usually, especially in living people, where it has blocked up a vessel and it needs to be pulled out. And so that can be an embolectomy or a thrombectomy. And so they tend to pull out these clots. Now, what he noticed was that he told me that he has been seeing these white clots for several years now. And so this is somebody who is speaking privately, not publicly. He recently placed a stent, and within 2 weeks, the stent clotted off. When he declotted and he pulled out a white clot. So we can confidently say that it occurs within a minimum of 2 weeks. And I would say that the clot was progressing over a 2 week period to obtain size large enough to cause a complete occlusion. I do have cases that I would say are white clots, however, do not have pathological confirmation. And this is one of the reasons why doctors are necessarily not focused on it, because it needs to be studied. And because of what happened with the film, Died Suddenly, where it appeared to be more of a conspiracy theory at the time, it has thrown the scientific and medical community off from doing the kind of work that needs to be done. And this is just an example of what these white clots look like. This is very stringy, rubbery, different from the dark, normal clotting that occurs. And this is the more like the grape jelly like clots. This is normal. This is not. And we know that they have a lot of amyloid in them because they've been studied. There are a number of other proteins in them that are unusual. The whole situation is quite unusual. And as I said, initially I thought this only occurred in bodies, so after death. But when a whistleblower had shared with me, this is the kind of clot that they pulled out from the inferior vena cava. And so this was a massive clot. And you can see it's a mixture of the white and the red clots. So we know it's happening in the living, and we just don't fully understand the mechanism. And the first doctor who does histology came out recently and shared that he had also pulled it out of a patient who had died. So we know this is occurring. So we have some important questions about what are the mechanisms. So this is where I'm going to quickly. We know that a significant proportion of these clots are composed of hemoglobin subunit beta, and as well as fibrinogen. So these four: hemoglobin subunit beta, fibrinogen beta, fibrinogen gamma, and the hemoglobin subunit alpha are the primary proteins that are involved in this. It's important to note that hemoglobin in the broken down form is not typical in a clot. So there is something happening that is causing red blood cells to break apart, which is what causes these unusual patterns or contributes to it. So here is something that I'd taken from one of the presentations when I was doing the science of it. And so I'm giving you a quick whistle stop tour about what I think could be happening. So one of the mechanisms that the spike protein seems to interfere with is in relation to the red blood cell and the stability of the red blood cell. Normally, in the lining of the red blood cell, this represents the cell wall, and it has some enzymes in it that are continually working to keep these lipoproteins on the inside. So, this is the inside of the cell, this is the outside. And these flipase proteins are working all the time to try and make sure that these are not exposed, because if they are, it increases the risk of clotting. One of the things that happens with regards to the spike protein is that it can inactivate this flipase. And so then what happens is that you end up with more of these phosphatidylserines outside the cell, which will trigger the red blood cell to become more likely to be damaged and lysed and release the hemoglobin from the inside. And so this mechanism is one that is known to occur, and we need to try and understand if this is the reason why we're getting hemoglobin in some of these clots. And what would then happen is that you would have exposure of the red blood cells, triggering a clotting process. Now, in this clotting process, it shows platelets, but it does seem that the platelets are not really involved as much in this abnormal clotting. It's a lot of fibrinogen, a lot of broken down red blood cells, as well as many other proteins, phosphorus, tin, and so on present in these clots. So you need to get that background to understand what it is that I'm speaking about. And just a reminder, if you've just joined us, that this is the email communication. Somebody was seeing white clots for several years. They put in a stent. The stent clogged in 2 weeks. And when they went back in, they pulled out a white clot. And so they know that it takes about 2 weeks for this to occur. So this is what I think happened in the context of the situation. So to understand what happens with a stent blockage, we didn't know what kind of stent. It could have been a heart stent, it could be a stent in the leg, but the premise with regards to the stents works the same. So this is an example of a heart stent where this artery is blocked by the plaque. They put the stent through, they feed it through with the wire, then they expand it so you can see the plaque is squeezed to the side, and then the stent remains open, allowing blood flow to occur. So this is how many people are managed who have underlying heart disease to reduce the risk of heart attacks, or to manage angina, or if it's in the leg, and to manage some of the symptoms associated with poor blood flow to the legs. So that's the premise of a cardiac of a stent, and it can be in any artery that is relevant. This is a closer up look with regards to the stent, and you can see here it has been opened, the blood flow is going through, red blood cells are running along, the plaque has been squeezed to the side, and in some stents they release drugs which reduce the risk of clotting, and these tend to be the stents that are put in most situations to try and reduce the risk of the stent blocking. So stent blockage is not unusual. It's just that what they said in this case, it wasn't a normal clot, but it was a white clot. And so, in my imagination, this is what it would look like. Here you have the stent with this white amyloid clot blocking the stent. This is what a normal clot would look like. And so, this blockage here now, within 2 weeks, seems to form and prevent blood flow through that artery. That is really important because a 2 week period of time, and this is what I've been saying, is that the mechanism seems to be autoimmune. It doesn't happen immediately, but these clots seem to occur over a period of 2 to 3 weeks. It doesn't happen in a day or a few hours. And I think that people have to be generally quite sick in order for this to occur. So, just a reminder, it's different from the normal clot where we have platelets and fibrin and red blood cells. These white clots tend to not be free red blood cells, which is why they're white, but they're broken out. So the cells release the hemoglobin, which get trapped with all the fibrin and everything else to create a white mush that is very fibrous and elastic. These are serious, critical pieces of information, and my responsibility is to continue to keep focus on it so that it doesn't get lost. I am not letting anyone get away with saying they never knew about this. As many people as possible need to know it is occurring. We don't fully understand the mechanism, and everyone has the responsibility to raise awareness and try and see if we can get the correct investigations done. That's my job that I'm trying to do, and I hope you appreciate the time it takes to do it. As a final reminder, look out for this presentation. COVID boosters, are they putting you at risk? This is primarily focused on IgG4 and sharing with you recent information from a paper and putting the whole thing together. We still have a lot of work to do. And I recently shared a post that based on the scientific extrapolation, it takes 20 years for this kind of thing to be acknowledged. This is too serious, too important for us to leave for another 15 years. We need to get this answered now. Let's keep working at it. Have a great evening.